So in this video, I'm going to solve the problem 2 to the power of 19 minus 2 to the power of 18. So I want to find the value of this problem. So for my solution, I'm going to start by rewriting my problem here. So 2 to the power of 19 minus 2 to the power of 18. And to start off, I'm going to rewrite 19 here as 18 plus 1. So I get 2 to the power of 18 plus 1 minus 2 to the power of 18. And if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 18 plus 1 is equal to 2 to the power of 18 times 2 to the power of 1. And now I have this minus 2 to the power of 18. Now from here, because I have two terms that are the same, I can factor out 2 to the power of 18. So I get 2 to the power of 18 times, 2 to the power of 18 times 2 to the power of 1 divided by 2 to the power of 18 is simply just 2 to the power of 1, and negative 2 to the power of 18 divided by 2 to the power of 18 is negative 1. So I get 2 to the power of 18 times 2 to the power of 1 minus 1. And this is equal to 2 to the power of 18 times, 2 to the power of 1 is 2, so I get 2 minus 1, which is equal to 2 to the power of 18 times 1, which is equal to 2 to the power of 18. So I get 2 to the power of 18 as my answer. Now, there is actually another method of solving this problem. So going back, our original problem was 2 to the power of 19 minus 2 to the power of 18, right? And what we did was we wrote 19 as 18 plus 1, and we solved it by factoring out 2 to the power of 18. So now, what if instead of rewriting 19, I rewrite 2 to the power of 18 as 2 to the power of 19 minus 1. Now, the way I'm going to solve this is I'm going to rewrite 19 minus 1 as 19 plus negative 1. Now, I can still use that property that states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 19 plus negative 1, that's going to equal 2 to the power of 19 times 2 to the power of negative 1. So I can still do it. Now from here, my greatest common factor from these two terms is 2 to the power of 19. So I get 2 to the power of 19 times 1 minus 2 to the power of negative 1, which is equal to 2 to the power of 19 times 1 minus 1 half, which is equal to 2 to the power of 19 times 1 half, which is equal to 2 to the power of 19 times 2 to the power of negative 1. And 2 to the power of 19 times 2 to the power of negative 1 is equal to 2 to the power of 18. Alright, so in this equation, we have x times x times x plus x is equal to 30. So my only variable here is x, so we know that we're going to solve for x. So for my solution, what I'm first going to do is start by subtracting 30 on both sides. So if I subtract 30 on both sides, I get x times x times x plus x minus 30 is equal to 0. Now from here, I can rewrite this as x to the power of 3 plus x minus 30 is equal to 0, because x times x times x is the same thing as x to the power of 3. And now A lot of people would think this is a quadratic equation, but this is a power of 3, not a power of 2, meaning we can't use the quadratic formula to solve this equation, or we can't simply use the normal method of factoring. So to actually solve this, what I'm going to do is rewrite negative 30 as negative 27 minus 3. And the reason I did this is because 27 is the same thing as 3 to the power of 3. And notice how we have something to the power of 3 plus that same number and another something to the power of 3 minus that same number. So now I'm going to group the two powers of 3's. So I get x to the power of 3 minus 3 to the power of 3 plus I'm going to group the powers of 1. So plus x minus 3. Now from here, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, a is equal to x and b is equal to 3. So I get x minus 3 times x squared plus 3x plus 3 squared, which is 9, plus I have my x minus 3 at the end, is equal to 0. Now from here, notice how both of these terms have x minus 3 in them. So what I'm going to do is factor out x minus 3. So I get x minus 3 times x squared plus 3x plus 9 plus 1 is equal to 0. And this is equal to x minus 3 times x squared plus 3x plus 10 is equal to 0. And now I have two equations from this. I get x minus 3 is equal to 0 and x squared plus 3x plus 10 is equal to 0. So for x minus 3 equals 0, this is fairly simple. All I have to do is add 3 on both sides. So then these two cancel out, and I get x is equal to 3. So this is one solution of x. Now, for x squared plus 3x plus 10 is equal to 0, this is a quadratic equation, meaning I can use the quadratic formula to solve this. So recall that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 3, and c is 10. So I get x is equal to negative 3 plus or minus the square root of b squared, which is 3 squared, which is 9, minus 4 times a, which is 1, times c, which is 10, all over 2a, so 2 times 1. And now this is equal to negative 3 plus or minus the square root of 9 minus 40 over 2, which is equal to negative 3 plus or minus the square root of negative 31 over 2. And negative 31 is the same thing, the square root of negative 31 is the same thing as the square root of 31 times the square root of negative 1. And if you guys already know, the square root of negative 1 is equal to the imaginary number I. So I get negative 3 plus or minus the square root of 31i over 2. And this is actually two solutions. X is equal to negative 3 plus the square root of 31i over 2, and x is equal to negative 3 minus the square root of 31i over 2. Now from here, going back, my original equation was x times x times x plus x minus 30 equals 0. Well, these two are complex solutions, so we can't really check them, and they are not actual solutions. But what we can check is 3. So if we plug in 3, we get 3 times 3 times 3 plus 3 is equal to 30, which turns into 27 plus 3 is equal to 30, and I get 30 is equal to 30.